Hello guys. Living in the age of digital technologies demands security in every corner, to protect your identity and your personal life. Therefore, many companies are concerned with providing secure passwords. These companies also need to get the correct number of passwords which are not only stronger in strength, but also serves the available and future customers. Similarly, they tend to develop passwords, which are hard to crack and stolen. These passwords are now embedded with special characters, numbers, and the combination of upper and lowercase letters, so that cracking them takes years and years, if tried by using the round-robin fashion for password guessing. In this video, we are going to solve and see how these companies predict the number of passwords and their time complexity. Let's begin now, and don't forget to subscribe to the Engineering Tutor.
Hello again. So this is the question number 2.43 in the book of Probability and Random Processes for Electrical Engineering by Alberto Leon Garcia, and this is the third edition of that book. In that book I have found this question, which I have seen as one of the most important questions in learning how to crack different passwords, and have been used in many years by many practitioners to crack the passwords. Okay, similar manner you also use in your daily life to crack different passwords or different passcodes of different doors or boxes. Okay, so what it is asking us to find, so a website requires that users create a password with the following specifications, and the password length ranges from 8 to 10 characters. It also includes one of the special characters which are given here. These are basically 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. These are basically the 24 characters. Okay, special characters are 24. No spaces. It shouldn't have any space in between any character. It may also contain numbers from 0 to 9, lower and uppercase letters A to Z, which are basically 26, and separately 26 here because this is the case sensitive. Okay, so what is it asking us to find? That how many passwords are there. If you can use the password length from 8 to 10 characters, in which you must have include the character or the special character out of these 24 characters. So how many passwords can you get, and how long would it take to try all passwords if a password can be tested in 1 microsecond? 1 microsecond, and this 1 microsecond is 1 into 10 raised power minus 6 seconds. Okay, so now let me use this green color for solving this question here. In solving it, what we have, basically we have, let me consider again this block here, and it will be composed of 9 slots. Okay, in these 9 slots I should have, basically in the first slot I should have one of these 24 characters. In the second slot I should also have one of these 24 characters, and up to the nth slot here I should have the one of the 24 characters as well. Okay, so either this will have one of these characters, or this one, or this one, or this one. So this is the basic condition for any password to be valid, is that one of these 24 characters should also be here. Okay, so if all the others are available and none of these 24 characters is available, so that password will be non-valid. Okay, if none of the 24 characters are available. So what would we do? This is the OR condition, so we should write plus with all these 24 or these choices. So what will happen? 24 plus 24 plus 24 up to the 24th element here. So it will basically be 20 n multiplied by 24, or 24n. Okay, so that is the basic condition for my passwords to contain the special characters here. Okay, so that is the first rule, and let me call it equation 1. Okay, after it, let me have now again. So for condition number 2, one of the n slots has been captured by the special character. So how many slots now are left? So n minus 1 are left now. Okay, so out of these n slots now how many slots are left? N minus none, n minus 1 slot. So how many characters can basically occupy those spaces? So in these n minus 1, I can also use the 24 special characters, because it is already given that at least one special character should be included. So more than one can also be included here. Similarly, the 26 small alphabets can also be here. So 26 here. Similarly, 26 uppercase letters can also be included here, and similarly the numbers from 0 to 9 can also be included here. Okay, so how much is it? It will be 26, 26, 52, 52, 10 is the 62, 62 plus 24 is 86. So I can have 86 characters. Okay, so in these n minus 1 slots, okay, as I have now n minus 1 slot, in each slot how many possibilities of the characters will I have? Here 86, here 86, here 86, and up to this one. Okay, so this is also the sampling with the replacement task, in where any of the 86 character can be used here, and so on for each and every slot here. Okay, so how many characters would I have here? So this is basically the AND condition, because all the n minus 1 slot has to be occupied. So that's why these would be 86 multiplied by 86 multiplied by 86 up to the 86th n minus 1 character. So how many elements would I have here? I will have 86 n minus 1 choices here. Okay, so now the basic condition is here for the for the nth character, and this is for the n minus 1 characters. What would happen now? Here let me use the black color here again. So here with this 24 n into 86 n minus 1, I will have passwords for n characters. Okay, so that is the password for the nth number of characters, and similarly here I have the minimum length of the password is 8 and the maximum is 10. Okay, so let me write it for the all possible lengths. Okay, so the possible lengths can be 8, n is equal to the 8 plus n is equal to the 9 plus n is equal to the 10. Okay, why am I using plus here? Because any of these three can be used here. It can be 8 or 9 or 10 as well. Okay, so now putting the values here, what I will get here? I will get here 24 into 8 into 86 raised to power 7 now, plus 24 multiplied by 9 multiplied by 86 raised to power 8 now, plus 24 multiplied by 10 multiplied by 86 raised power 9. Okay, so what will be the answer here? And by calculating it, I will get 6.24 into 10 raised power 19 passwords. So these are the total number of passwords which I will obtain from the conditions which are given here. Okay. So these are basically the passwords which are given from the conditions mentioned here. Okay. So what is the next step? In next step we have to find out that how long would it take to try all password. Is a password can be tested in 1 microsecond. Okay. So these are basically the passwords here, and in B here, time to crack all passwords is equal to that is basically the total time. So time for one password multiplied by the total number of passwords. Okay. So the time for one password is 1 microsecond, that is 1 × 10⁻⁻⁶ multiplied by 6.24 × 10⁻⁹, and now using it I will get 6.24 × 10⁻13 seconds here. Okay. And converting it into the years here. Okay. What would I do? I would do 6.24 divided by the in 365 days. In each day I have 24 hours. In 1 hour I have 60 minutes, and in 1 minute I have 60 seconds. Okay. So 6.24 10⁻⁹, and from by solving it from this one, what I will get? I will get the 2 into 10⁻⁶ years. Okay. So this is the time required to crack all the passwords, and this type of technique in which I have to follow all the number of passwords is called the brute force algorithm, in which I will follow through all the passwords unless and until I will get the password which I need. Okay. So that is the question which I found very important for you to grasp the concept of, and that's why I have solved it alone and did not mix it with other question like I have solved the previous questions. Okay. So I think it's enough for today. You have grasped the concept which is necessary to solve these kind of questions.